Good morning, students. Last time we studied de Broglie wave concept of electron and its verification. Now, the next chapter is quantization of angular momentum and de Broglie equation. For this, Bohr in his model said that when electron is moving at a definite place, that is in an orbit, then its angular momentum is quantized. It means that the value of angular momentum mvr is equal to nh upon 2 pi, and he said that the value of n is a whole number. Now, why in the angular momentum of moving electron the value of n is a whole number couldn't explain by the Bohr. This is explained by de Broglie wave concept. De Broglie said that when electron is moving around the nucleus, a wave is associated with it. Thus, the electron will move only at the place around the nucleus where the waves are complete. That is, the wavelength associated with wave of electron is a integral multiple. That means if we see here in a picture, if electron is moving around the nucleus, then its wavelength should be an integral multiple. If it is here, it is 6 or 5 or 4, but it couldn't be 5.5, 4.5, 3.5 like this. If the waves are not complete or the waves without phase, then the electron will not move such a place. It will move only when the waves are in phase. So, the Bohr said that the place where the electron is moving around the nucleus, that is the orbit, is formed at a definite distance from the nucleus. Why that they moves at a definite distance, or the orbits are formed at a definite distance from the nucleus couldn't explain by the Bohr, but de Broglie said that electron will move in a place where the waves are complete. So orbit will form at the place where the waves are complete or the wavelength is a integral multiple, and where the wavelengths are not an integral multiple, the orbit will not form and the electron will not move such places. So, of course, the Bohr said that orbits are formed at a definite distances from the nucleus, but couldn't explain by the Bohr. It explained by the de Broglie wave concept that the orbit are at a definite distance from the nucleus where the waves are in phase or complete, or where the wavelengths are integral multiple. Also, de Broglie said that when the wavelengths are integral multiple in an orbit, then we can say the circumference of the orbit should be integral multiple of the wavelength, or we can write that the circumference of orbit, that is 2 pi r, is equal to n lambda, where lambda is the wavelength and that is the whole number of the wavelength, that is integral multiple, where r is the radius and the value of n will be 1, 2, 3, 4, 5, etc. By putting the value of wavelength from the de Broglie equation in this equation, we can write that 2 pi r is equal to n h upon mv, because we know that lambda is equal to h upon m into v. So, or we can write from this equation the mvr is equal to nh upon 2 pi. So, Bohr in its postulate of a Bohr model, he said that the angular momentum of a moving electron is quantized. It is always equal to nh upon 2 pi, where n is a whole number. Now, this value, where Bohr brings this value, couldn't explain by the Bohr. Just imagine, but it can explain by de Broglie wave concept, he said that the 2 pi r is equal to nh upon mv. So we can write mvr is equal to nh upon 2 pi, and n is always a whole number. It's an integral multiple of a wavelength. So this quantization concept of the Bohr is explained by the de Broglie wave concept. Thank you. Next we will study the uncertainty principle.